A Hailstone sequence begins with a positive m. If m is even, divide it by 2. If m is odd, triple it and add 1. Repeat until 1 is reached. Create a 2-column table with positive integer m in the first column and the length of the Hailstone sequence starting at m in the second column. Of course, this is only going to concern numbers and Hailstone sequences up to 100. The important concept here is that for the Hailstone problem, you don't need to work down from a number. Instead, you can build up. These are the rules for the Hailstone problem, and so inverting the rules so that we can build up would look like this. We can draw this out like this. Pause the video and take some time to try and understand what's going on. It follows that the length of any one of these nodes is 1 more than the length of everything below it, which is why the question hints towards recursion. So now let's look at the skeleton code and the table we start with. The left is the integer value, and the right is the length. We know that since we'll need to consider integers greater than 0, we'll need to consider PS. And since the right is where the recursion happens, we'll need to refer to Hailstone. And since the left is some integer, we put n, the column of integers from PS. And since we're incrementing the length, we'll put length plus 1. We've reasoned as to what the columns are. Now we need to consider the right conditions so our incrementation of length is accurate. It helps to think of m as the number highest on the graph so far, and this condition determining what the integer on top, or one node higher, is going to be. An integer n is going to be a node above m if it is even, and m is half of n. So one of our conditions is going to be n mod 2 is 0, and m is n divided by 2. Remember to nest it in parentheses so that it reads as one condition. The second way n can be a node above m is if n is odd and m is 3 times n plus 1. That's written this way. And a little thing you might have noticed about the Hailstone problem is that if you put 1 into the algorithm, it'll loop forever. To prevent this, in this last case, we'll have to consider every integer except 1. It looks like we're done and we can move on to the next question.